Amrita, hi.
Hello, Rijan.
Okay, we did up to question number 6 yesterday. Right, let's continue with question number 7 today. Have a look at this.
Okay.
Here, question says, what is the value of theta? There is a way to calculate this theta, Amrita. There's a formula. It says arc length. Let me write this one down. Arc length is theta multiplied by the radius, Amrita.
Yeah.
So, what is the radius length given here? 12, right?
Yes.
What is arc length?
9.6.
9.6. So, theta is 9.6 divided by 12. That will give us 0.8. 0.8 is in radian. Very well. So we're done with that. Let's go to question number 2. The question number 2 says, as in answer, question number B says, find the total area of the shaded region. So in order for us to figure out the area of the shaded region, area of the shaded region is area of the big triangle that you see here, AOB, minus area of the sector.
Right.
Okay, now how do we calculate area of the triangle, Amrita? You need to get height and base and half of height and base, correct? Area of the triangle is half base multiplied by height.
Right.
So what is height? Height is something like AM. It will be same as OM.
12.
It is 12, right? Now, how do we calculate AM, Amrita? Any suggestions?
Since it's a right angle,
We know that this is 0.4, right? Okay, take it forward with that.
So it's a right angle triangle, right angle at AMO.
Yes.
Yeah. We can use tan theta.
Tan theta, here we say tan theta by 2 perhaps, right? Is opposite side by adjacent side. That is AM divided by 12, right? Now we can calculate tan 0.4. Let me use my calculator for tan 0.4, Amrita. It is, give me a second, 0.4227, Amrita. Okay, now multiplied by 12 will give you AM. Is that correct? So now let me get that value for you. AM is equal to 5.0735.
Okay.
Is that okay? So now let us substitute that in here. Oh, by the way, we can now calculate area of the triangle. Area of the triangle is half base into height. That is half. Base is not 5.07. It's 2 times 5.0735. Correct? Now what is height? Height is 12. Let me use my calculator, Amrita. Area of the triangle. This one will be simplified as 60.88.
Right.
Okay. Now we are done with that. Let me remove all of these things for now. Let's calculate area of the sector. Thank you. Area of the sector. So there is a formula for area of the sector. Theta multiplied by r square divided by 2. So now here we can't anymore take 0.04. This time the entire thing is what we need. Correct, Amrita?
Right.
0.8 multiplied by 12 multiplied by 12 again divided by 2. Okay, now this will give us 57.66, Amrita.
Okay.
And let us subtract sector from the triangle. That will give us 3.28. Clear so far, Amrita?
Yeah, it's clear.
Okay, let me do one thing. Instead of erasing, let me drag and drop it in all here. Belongs in here. And similarly, this belong in here. Okay, Amrita, let's continue with the last question. Find the total perimeter of the shaded region. How do we calculate perimeter, Amrita?
the sum of the
So
all the
we
sides. Yeah.
need to add up this piece, this,
The border. Yeah.
this, and this, correct? However, to make it easier, the entire curved length is 9.6.
Right.
So we need to calculate perhaps this small segment, let's call it x. Okay, now let's use whatever we have done earlier. I'm going to drop this perpendicular. Sorry, some issue with my computer. Give me a second, Amrita. Okay, let me use it by hand. Sorry. Okay, anyway, Amrita, we have this length as 12, and this is 0.4.
Yeah.
Correct, Amrita. Can you tell me that trigonometric function that connects
Yeah.
OA and OM? Which one is that?
That's sine theta.
Maybe sine. In order for you to use sine theta, it's okay, Amrita. We can use actually 0.5, whatever we had, 5.0735. I think I like that. 5.073. Let's use that one. Then you can actually use sine, Amrita. No problem. If that's what you have chosen to do, that's fine. 0.4 is equal to 5.073 opposite side by hypotenuse. What is hypotenuse, Amrita?
12 plus x.
12 plus x. Very nice. So in order for us to extract x out of it, Amrita, how do we do this? Take everything else to one side, isolate x, right?
Right.
Okay. So that, let me do the calculation for you. It's going to be 5.073 divided by sine 0.4. Let me calculate that. That's 0.389 minus 12, Amrita. And that value is 1.0411. So this is the x value. So now, how do we calculate the perimeter, Amrita? So we need to take 2 times 1.0411 plus 5.073. That will be doubled, whereas the other one we don't need to multiply with the 2, Amrita. We can just take 9.6 itself. Am I making sense?
Yes, yes.
Okay, let me again use my calculator. This is going to give us 21.8. Is it clear, Amrita?
It's very much clear. Yes.
Okay, very well. Let me actually see if I can drag and drop. Doesn't matter. Let me continue to the next question. Amrita, here, question number 8 says, show that these two are same.
Right.
How do we do this, Amrita? Well, it's very simple. You just need to find the LCM, right? So, 3 multiplied by 2x plus 3. This essentially goes up. Plus 3 multiplied by 2x minus 3. Divide this whole thing by 2x plus 3 multiplied by 2x minus 3. Is it okay? Let's simplify this, Amrita. This will be 6x plus 9 plus 6x minus 9 divided by 4x square minus 9. Okay, let's cancel the terms that has to go.
Right.
12x divided by 4x square minus 9. Done?
Yes.
Okay, let's proceed, Amrita.
Yeah.
Hence, well, obviously based on what we have seen earlier, do the integration. Okay. And it says it has to be written with 1 logarithm plus 1 arbitrary constant. Okay, let's do this. This is same as that we have already seen those two factors, which are 3 by divided by 2x minus 3.
Right. Yes.
2x minus 3 and minus or plus 3 divided by 2x plus 3. Well, integrate both of them with dx. That's meaning of the question, right?
Right.
Okay, let's do this. 3 can be pulled out. and you will have ln 2x minus 3. However, think backward a little bit, Amrita. If I had differentiated this using chain rule, I will be differentiating 2x again, correct? And there will be a 2 coming out of it. So
Yes.
we need to consider that. Well, you could use the substitution method, but I think by now you can easily do without it.
Yeah.
Plus integrate, again 3 can be pulled out. Let's do the same thing on the other side. Ln 2x plus 3 again divided by 2 with a constant c. This is okay, Murtha? However, we cannot leave it at that. Question says it can't be elaborate form like this. It should be just a single logarithm.
Yeah.
So Amrita, first of all, I can pull out this 3 by 2.
Yes.
And then 2 logarithms added together is same as inside the logarithm they are multiplied, correct?
Yes.
2x minus 3 multiplied by 2x plus 3. For simplicity, Amrita, let me actually mention it here. Log a multiplied by b is same as log a plus log b. Same thing, we have inverted it here. Is it okay so far?
Yeah, it's fine.
Okay, now let's simplify the inner part. It's going to be 4x square minus 9. Right?
Right.
Okay, Amrita, what do we have? Okay, so look at this. There is ln 3 by 2 and plus c. How do we think about this one, Amrita, where you have 3 by 2 outside the logarithm? So how do we address that?
So 3 by 2 can be the power of 4x square minus 9.
Correct, Amrita. So this can be rewritten as ln 4x square minus 9 to the power 3 by 2 plus c. Is it okay, Amrita?
Yeah, it's fine.
Okay, now have we followed exactly what they have asked us to do?
Yes.
Yes, we have, Amrita. So this is what you would want to keep in mind. Okay, now let's continue to the next question. Question number C says, same thing, integrated from 2 to a, and answer is given to be this.
Okay.
Okay, so earlier we have seen this thing is essentially, Amrita, ln 4x square minus 9, we have seen it 2 minutes ago, to the power 3 by 2, right?
Right. Yeah.
Now, because it is definite integral, we can ignore that c thing, but here it has to go from 2 to a. So let's substitute it, Amrita. So it's going to be ln 4a square minus 9 to the power 3 by 2 minus ln. Substitute 2 inside this, Amrita. So it's going to be 4 into 2 square minus 9. So that will be 16 minus 9, 7, right? So that's going to be 7 to the power 3 by 2. Is it clear, Amrita, so far?
Yeah.
Okay. Now, when we simplify this further, Amrita, what will this give us?
So we can write it as division ln.
You know what? At this stage, what I suggest is, let us take this one. Let's simplify this further, Amrita. This is same as ln 5 to the power 5 multiplied by 5 1 by 2, right?
Yeah.
So that will be ln 5 to the power 3 by 2, Amrita.
Yes.
Okay. Now let us use all of it. So the entire thing is ln 5 to the power 3 by 2 is same as ln 4a square minus 9 to the power 3 by 2 minus actually, why don't we take this minus to the other side, Amrita? Okay, plus
But can
ln
we can write it as ln 4 square minus 9 divided by 7. The entire power is 3 by 2. Okay.
Again, Amrita?
Yeah, I think it's the same thing either way.
Same thing, right? Now maybe with these numbers and everything, maybe we could actually combine these things. So here there are two lawns together, Amrita, on the left side. Okay, so it is essentially lawn 7 multiplied by 5 to the power 3 by 2.
3 by 2.
Correct,
Yes.
Amrita? Is equal to ln 4a square minus 9 to the power 3 by 2.
Right.
So at this stage, let us take everything to the power e. So ln will get cancelled with e. So what we have is 35 is going to be equal to 4a square minus 9.
Okay.
Now from that, 4a square is 44. A square is 11, A is plus or minus 11, okay,
Minus 11,
root
yeah.
11. Now in this kind of cases, Amrita, before we conclude this, we may need to check in the question if there is any condition given, Amrita.
Yes, it's given.
What is the condition given, Amrita?
A is greater than 2, so can't be negative.
Exactly, A is greater than 2, so we don't need to consider the negative value, so it's only plus root 11. So keep that in mind.
Yeah.
Okay, we are done with that question, Amrita. Let's continue to the next one.
Okay.
Look at this. Here it says arithmetic progression has second term minus 14 and sum to 21. Well, kind of a strange wording, Amrita. But okay, let us translate this into something meaningful. How do you translate this, Amrita? So,
it's an arithmetic progression, yeah.
So this, let us say T2 is equal to minus 14 and S21 is equal to 84. But just writing this is not very intuitive, but from this we can actually apply the formula for Tn. Do you remember the formula for Tn? It doesn't imply this. So Tn is equal to T1 plus n minus 1 multiplied by D, right?
D.
So we could actually apply this. So this will be T1 plus D is equal to minus 14. And this one, what is the formula for Sn, Amrita?
N by 2.
N by 2.
Into 2T1.
2T1 plus
N minus
again,
1
n minus
into
1
D.
into D. Right? So let us do the same thing here. 2T1 plus 20D multiplied by n by 2. In this case, 21 terms. So it is 21 divided by 2 is equal to 84. So this is the advantage. So we have got these two simultaneous equations to be solved. Let us simplify it. So how do we do? Let me do it this way. Why don't we take this 21 divided by 2 to the other side? So 2T1 plus 20D is going to be 21 and 84 can get cancelled out. Correct, Amrita? How many times? 4 times.
4 times, yeah.
So this is going to be 8.
Right.
Now let's copy the other one. T1 plus D is equal to minus 14. Okay, so what do we need to do at this stage?
We can simplify this first equation as T1 plus 10D is equal to 4.
Isn't it slightly better, Amrita, to multiply this one and make it a 28?
Okay.
So let us subtract. So that's going to give us 18D is equal to, by the way, this is going to be minus 28, right? So 18D is equal to 8 minus 28. How much is it? Plus
36.
Plus 36, right?
Right.
So from that we get D as how much, Amrita?
2.
So in that case, substituting in the first one here, Amrita. So what will be T1?
Minus 16.
Yes, that's correct. Minus 16. So we are done with this. And question is not over yet. Find the first term and the 21st term. So we have calculated the first term. We need to calculate T21. So it's going to be minus 16 plus n minus 1. What is n minus 1? 21 minus 1, 20 multiplied by D is 2, right? So how much is it? 40 minus 16, 24.
Right.
That's it. So we have got these two. That's the answer to the first part.
Right.
Let's continue to the second part. So what does it say? Geometric progression has second term 27p square. So here it's not arithmetic progression, it's geometric progression. So how do we understand this 27p square? T2 is equal to 27p square. Correct?
Right.
So in geometrical series, let's say if I call first term A, second term will be A multiplied by a factor, right?
R.
AR is how we write it. So here it is A
Right.
multiplied by R is 27p square.
Right.
Is that correct, Amrita? Okay.
Yes, yes.
Now, from this one, let's continue. And the fifth term is p square. Okay, so let's do that.
To the power 5.
T5 is just p to the power 5. Okay, let's translate that one. So it is a r to the power 4 is equal to p to the power 5, right?
Yes.
Okay, Amartya, these two combined will give us whatever we if you divide. So if we, can I rewrite it a little bit? Okay, not these two, Amartya, my fault. Actually, if we combine these two, okay, so we can actually divide the left term from the right term. So it will be r to the power 3 is, let's do it properly. Why am I skipping all the steps? Okay, r to the power 4 divided by ar is p to the power 5 divided by 27p square. Agreed, Amartya?
Yes.
So on the left side, terms will get cancelled out. R square, r cube is what's going to remain. What do we have on the right side, Amrita?
P cube by 27.
P cube divided by 27. So from that, question is asking find r in terms of p. That implies r is equal to, it's very easy, p by 3.
Yeah, P by 3.
Done? Okay, let's go to the next one. Hence, find in terms of p sum to infinity of the progression. Okay, so here you may want to remember this formula, Amrita. S infinity, provided this r is between 0 and 1. Okay, only then it works. It is going to be something like this, Amrita. Here, 1 second. Let's look at this.
A
divided by 1 minus r.
R. Yeah.
Okay, so here we need to first calculate the first term. So r is this, Amrita, and a. Okay, let's do this. AR is equal to 27p square.
Right.
R is equal to p by 3. So A will be 27p square divided by R. That will be divided by
P by 3. Yeah.
p by 3. So when we simplify this, it is going to be 81p.
Right.
Okay,
Yeah.
so 81p is the first term, or A. So let's substitute all of those things in here. This will be 81p divided by 1 minus, what is the value of r? We have already calculated. It is p by 3. Now let us simplify this. So it's going to give us 81p divided by 3 minus p by 3. 3 minus p by 3. Yes, it is correct. So that will give us 243p. Take 3 to the upper side.
Yeah.
Divided by 3 minus p.
Yeah.
We need to leave it at that because question says in terms of p, so we don't have to worry. Right? Got it? Shall we proceed?
Yeah.
Okay, given that sum to infinity is 81, find the value of p. Now we have already calculated sum to infinity and they're saying that value is equal to 81.
Yeah.
This is equal to 81 is what they're saying, Amrita.
Right.
Okay, so let's use it. I don't want to use this ink. Let me change it. Okay, so 243p divided by 3 minus p is equal to 81. It's just mechanical calculation at this stage, Amrita. 243p is equal to 243. 1 second. Yeah, you're right. 243 minus 81p, right?
Yeah.
So from that you get subtract all of these things, add 81 to this is going to be 324p is equal to 243.
Right.
Therefore p is equal to 243 divided by 324. Remember, Amrita, this is top part. I can factor it out as 81 multiplied by 3.
Yes.
And the denominator is 81 multiplied by 4.
Okay.
Now, how do I get this intuition? 8's multiplication table says 8 into 3 is 24, and 8 into 4 is 32. So we can intuitively reach that. Anyway, so in this case, 81 and 81 will get cancelled out. It's just 3 by 4. That's the answer to the question. Done. So shall we move on to the next question?
Yes.
Okay. Have a look at this question and you tell me what is the insight that you want to use to solve this question.
So I would first simplify the left hand side.
Yes, we need to keep some trigonometric, I think they are called identities, yes. So
Yes.
sine square theta plus cos square theta is equal to 1. And similarly, secant square theta, this time it's minus tan square theta is equal to 1. Similarly, cosecant square theta minus cotangent square theta is also equal to 1. So we keep these in mind. Most of the time you can use that to simplify whatever we have. Okay, now have a look at this. As you have said, we will start with the left side. So we have two different denominators, so we need to unify them to add or subtract, right? So it's going to be sec theta plus 1 divided by sec theta minus 1 multiplied by sec theta plus 1. Yeah, I didn't have to do this way, but anyway, as we have started, sec theta minus 1 divided by sec theta plus 1 multiplied by sec theta minus 1. Isn't that correct, Amrita?
Yes.
Yeah, I have overcomplicated. I could have simplified it. But anyway, we get the we get where we are going with this. So now we have the same denominator.
Yeah.
So it will be just this and this will get cancelled out. This minus will make it plus 1. So it's going to be 2 divided by, Amrita, what is the denominator? Denominator will still be the same thing, correct?
Right. Sec square theta minus
we can
1.
multiply this. It's going to be secant square theta minus 1. Is it clear? Now,
Yes.
using this identity, secant square theta minus 1 is tan square. So it is 2 divided by tan square theta. So which is same as 1 by tan square is cot square.
Cotangent, yeah.
So it's going to be cot square theta. Done. We have shown that.
Yes.
Okay, now let's continue to the next one. Here it says hence, so that means we may use the information above.
Right.
Solve this one. Now, look, before we use this, Amrita, look at the difference between the first one and the second one. In the first one, it is just theta. Here, it is 2x.
Right.
So when we simplify this, you need to keep that in mind, Amrita. So this will be 2
is equal to
cot square 2x
right.
is equal to 6, Amrita.
Right.
Okay, let's simplify this further. So this will give us cot square 2 theta is 3, and it is same as 1 by tan squared 2 theta is equal to 3. Isn't that correct, Amrita?
Yeah.
So when we simplify it, what we need to do is
Tan squared.
tan theta is equal to 1 by root 3 is what we have.
Plus minus
2 theta. Plus minus is there. Yes, you're right. Plus minus. Yes. Amrita, at this stage, people would directly jump into getting tan inverse. Okay, let us do that. But most of the time, Amrita, you would want to think about this. Do you directly want to jump into tan inverse in your calculator, or you would want to think a little bit, Amrita? Okay, so period of tan is pi.
Yes.
Okay, that means at every pi it will repeat itself. Isn't that correct?
Yes.
So keeping that in mind, let's proceed. So 2 theta is going to give you, when I substitute this in the calculator, Amrita, let me use this. Either it says pi by 6 or minus pi by 6, Amrita. Okay, now we need to do that thinking again, Amrita. It won't be only this. You would want to consider other possibilities. So that means plus or minus n pi.
Yes.
That we need to consider at this stage, Amrita.
But it's only between minus 90 and 90, so do we consider?
Correct. So with that in mind, we need to consider n pi. Okay, so you don't need to consider maybe like 3 possible values. You may need to consider 1 or 2 values. By that time, you will see it is going to go out of that given range, Amrita. Okay, so let us look at this, Amrita. I want you to do this for me. Okay, let us do this calculation. Pi by 6 plus pi, what would that give us?
7 pi by 6.
Pi by 6 minus pi.
Minus 5 pi by 6.
Minus 5 pi by 6. Now, minus pi by 6 plus pi. Minus 7 pi by 6. Correct? Oh, sorry. Minus 5 pi by 6. Correct, Amrita? Similar.
Plus 5. Plus 5 by 6.
Oh, sorry. Plus 5 pi by 6. Minus pi by 6 minus
pi.
pi will give us minus
7
pi by 6. Correct, Amrita? So
Right.
the possible values we are considering are these ones. Pi by 6, minus pi by 6, then 5 pi by 6, then minus 5 pi by 6, 7 pi by 6, and minus 7 pi by 6. Is that okay, Amrita? These are the possibilities for our 2 theta, Amrita. Now let's go, oh, by the way, let's do one more thing. Okay, from this, let's calculate theta also, Amrita. Okay, so theta will be pi by 12 minus pi by 12, 5 pi by 12, minus 5 pi by 12, 7 pi by 12, and minus 7 pi by 12. Now at this stage, I want to seriously consider what you have told me. Shouldn't it be within this? That is between minus pi by 2 and pi by 2. Correct? That's what you are concerned about, Amrita. Let us see which of them are beyond that. This clearly is within that. This clearly is within that. Correct, Amrita?
Right.
If it were to be 6 pi by 12, then you would know that it is pi by 12. Correct? Sorry, pi by 2.
Yeah, it's within that.
So this is within that. So I'm going to accept this one. Similarly, I accept this. Now let's look at this one.
Other two are not.
These two are outside because 6 pi by 12 is the borderline and not within whatever they are saying. It's not equal to.
Right.
So 7 pi by 12 is already out. So we will discard these two. Okay, so these are the possible values of theta. So in this question, Amrita,
Shouldn't this be in degrees? Like, will my marks be cut if I use radian instead of degree?
I don't believe so, but take out your calculator and you can actually
Convert them into degrees.
put it in degrees. I personally prefer radian. It looks more mathematical than degree. Okay. Now, Amrita, I need to tell you something. In this kind of questions, Amrita, calculating up to this step is the easiest task to do. Okay. But the analyzing beyond that, what are the other possible values? Okay, is the key thing. So you will have to spend some time analyzing this n pi thing. Now, this n pi thing works for tan, but if it is sine and cosine, it will be 2n pi plus
2n pi. 2 pi is the yes.
Correct. So let us continue to the next question. Solve this. Okay, this time it is 0 to 2 pi. Y goes from 0 to 2 pi. Okay, Amrita. Oh, by the way, here they have explicitly mentioned give your answers in terms of pi. Okay, fine. So, Amrita, how do we do this? Any suggestions?
So directly first calculate the inverse cosec inverse.
So it will be sine y plus pi by 3 will be 1 by 2.
Yeah, by 2, right.
Okay, so y plus pi by 3 is sine inverse 1 by 2. Let me use my calculator, Amrita.
Pi by 6.
It is pi by 6. It is pi by 6.
And the positive value is pi by 6.
Yes, Amrita. Now, after having got this, Amrita, y plus pi by 3, this is where we need to do our analysis, Amrita. This has to be dealt with the way that we have discussed earlier, correct? So it's not only this, it can be
pi by 6. Yeah. In the second quadrant, this is positive. So
plus or minus 2 and pi.
Yeah.
Right? Okay, let us see which are the values that we can actually get this. So,
Jijan, there is one more possible value. In the second quadrant also you'll get a positive half for sine. So that also I guess we need to consider pi by 6.
Amrita, you are right. Let me just show it to you. See, I know what you are thinking, but I prefer the...
Okay, we can get it by putting values.
I prefer sine graph itself, Amrita. As you have talked about this, let me try to help you to understand this. So sine graph essentially goes something like this. Isn't that correct, Amrita?
Yes.
And it continues. Now, it says it is equal to half. So that means there is a line that goes like this, Amrita.
Right.
Okay. So this pi by 6 that we have already calculated, Amrita, it is here. That is the most obvious value, correct? Now, let us see how do we get the other values, Amrita. It is fascinating. Okay, so in order for you to get this value, keep it in mind, Amrita. There is some kind of a symmetry between these two. Isn't that correct, Amrita? Okay.
Yes.
So in a way, easiest way to do this, if this is pi by 6, this will be, Amrita, by the way, this ends here at pi, correct? So pi minus pi by 6 will give you that value. Isn't that correct, Amrita? This one, it will be pi by 6 minus complete pi, Amrita. Because we have shifted the, maybe I don't think that's very logical to do that way, Amrita. Look at this one. This value is minus pi, Amrita. Do you agree?
Yes.
Okay, so this one will be minus pi by 6.
Right. Yeah.
Okay, similarly, let's do this one, Amrita. This will be exactly pi units away from the other one, or we could actually look at this, Amrita. This is anyway 2 pi, right?
Yeah.
So it's going to be 2 pi plus pi by 6, Amrita.
Right.
Okay, so these are the possible values for y plus pi by 3, Amrita. Okay, so let us get some of this, whichever is relevant for our calculation, Amrita. So how much is each one of them? How much is this one? It's going to be 6 pi by 6. Okay. how much is going to be this one? It's going to be 12, 13 pi by 6, right? Amrita, how much is this one? This is going to be minus 7, sorry, yeah, minus 7 pi by 6, correct, Amrita?
Yes.
Okay, I am not very sure whether we want it, but we may come back to that in a minute. So possible values that I have got here are minus 7 pi by 6, comma pi by 6, comma 5 pi by 6, comma 13 pi by 6. Is that okay, Amrita?
But I have a question, Teacher. Since, see, no, I don't have, yeah.
Okay,
I'm sorry.
no,
Yeah.
no problem, Amrita. Now let us calculate only y from it. That means we need to subtract pi by 3 in each one of these cases. Okay.
Right.
So
Right.
when I subtract pi by 3 from here, Amrita, minus 7 pi by 6. Pi by 3 is essentially 2 pi by 6. Correct, Amrita?
Yes.
So when I do that, what will that give us? Minus 5 by 6.
5 pi by 6.
5
Yeah.
pi by 6, right? Let's do the same thing here, Amrita. When I subtract pi by 6 minus 2 pi by 6, what will that give us?
2 pi by 6. Yeah. So minus 5 by 6.
Minus pi by 6. Let's do the next one, Amrita. What's the next one?
5 by 6.
minus 5 by
2 pi by 6. So 3 pi by 6.
3 pi by 6. Okay.
Yeah.
And from the last one, you
Minus
13 pi by 6 minus 2 pi by 6. How much is it? 11 pi by 6, right?
Yeah.
Okay. Now, Amrita, now you consider our range. It actually starts with 0, so I can eliminate this immediately. Isn't that correct?
Yeah.
So the only value, Amrita, you know what? I changed my mind a little bit. I may want to consider this value one more time, Amrita. Just want to make sure that I'm not missing out anything. So it will pick up and it will come back here. Okay. So that will be, this will be 3 pi, Amrita. Okay. So
Pi minus 5 is
exactly. So what is 3 pi minus pi by 6?
70.
Sorry, plus, minus, yeah.
Minus, yeah.
So
17 pi by 6.
17 pi by 6. So if I had 17 pi by 6 in this list, okay, 17 pi by 6, we will be subtracting 2 pi by 6 from that one. What will that give us?
15 pi by 6.
15 pi by 6.
And that's more than 2 pi.
Subtract 1 by 3 from that, correct? So it is still big. Okay. So only these two are acceptable values, Amrita.
Right.
That's it. Okay. For 4 points, that's a lot of hard work.
Yes.